All right, great song. Oh, had to let the chorus hit. All right, today we're talking about log properties. Okay, everyone remembers log properties from the years. I'm sure you've done these over the years. Everyone's favorite, I know. Today's song of the day, by the way, "Bad Self Portraits" by Lake Street Dive. A nice little Chicago band for you. I believe, I think, maybe, potentially, yeah, hopefully. Now that I said that, but either way, you guys should check them out. They're pretty good. I've seen them in concert. I've seen them live. They're a pretty fun show. Let's talk about exponential functions. So our last lesson was all about our exponential graph and shifting our exponential graph. Remember our key features. Our key points were 0, 1, 1, whatever our base was, and then our asymptote or horizontal asymptote was y equals 0, and that changed based on our vertical and horizontal shift. Okay. Well, log functions are basically our exponential functions. These two are inverse functions, okay? Meaning that they are able to reflect over the line y equals x. All right, so I'm going to show you this. You don't have this slide. Our exponential function looked like this from our last lesson. Well, the line y equals x is right there. The exponential, or excuse me, the logarithmic function is going to look like that. Okay, so they're inverses of each other, inverse operations of each other to a certain extent. Okay, one undoes the other, kind of. All right, so in order to switch from exponential form into logarithmic form, or from logarithmic form to exponential form, I call it the circle of life. But before we do that, let's talk about if they are inverses of each other. Then, remember, within inverses, our x's and y's switch. So one of our key features on the log graph will be 1, 0. Remember, our domain and ranges switch, b, 1. And then instead of a vertical or horizontal asymptote, I'm now going to have a vertical asymptote, and the equation is going to be x equals 0. Okay. To go from a log to a exponential, I just called it the circle of life. The base is 5. The exponent is 2. The answer is 25. Right there. So let's practice that. Write the log equation as an exponential equation. So since our base of our log is 2, our base is 2. I hop across, circle of life, 2 to the y, go back around, equals 16. Well, now I have to figure out 2 to what power gives me 16. I know that 2 to the second is 4, 2 to the third, so 2 times 2 times 2 is 8. 2 times 2 times 2 times 2 is 16, so that's 2 to the fourth power. And I would get that by guess and check. 2 to the third, enter. 2 to the fourth, enter. Okay. Switch from log to exponential. 2 is our base, so 2 stays our base. 2 to the y equals 1/2. Well, I noticed that 1/2 is essentially 2, but flipped. Like it's like 2 over 1, but flipped. Well, remember, if we have to flip a number, flip the fraction, anytime this happens, that gives me a negative exponent. Remember, 2 to the negative 1 is just 1/2. Okay, that came from our previous lesson. Base is y. Y to the 5th equals 17. Well, how would I solve for 17 here? Well, nothing to the 5th, there's no easy 5th power that gives me 17. So to undo our exponent, I need to take the 5th root of both sides to get y equals the 5th root of 17. How did I know to take the 5th root? Remember, if this was y squared, I take the square root. If it was y cubed, I take the cube root. All right. This exponent tells me the index of my answer. And I would just have you leave it like that. There is no 5th root of 17. Some basic log properties. If I have log base of any number and the 1 is right here, that's just going to be 0. Because anything to the 0 power would give me 1. If I have the log base be a b, so if these two numbers match, it's just, your answer is just going to be 1. Think about that. 3 to the first is 3. That's an example. If I have b log base b of b to the x, My answer would just be x. These are going to cancel each other out. We'll talk about that in a minute too as we get to our log properties. Same idea if I have a log, or if I have a number raised to a log with the same base, the x will just drop out. And if these are the same, our bases are the exact same, then I can set x equal to y. And again, I'm going to review these in a little bit here. Okay, let's talk about some more properties of logs. All right, change of base. Okay, change of base. If I have log base a of x, if I want to plug this into my calculator, because a lot of our old school calculators only have log base 10, like my TI-84 Plus here only does log base 10. Some calculators allow you to change a base, but if not, what I'm going to do here is take the log base, the log of x divided by log of a, which is a log of base 10 of x divided by log of a. So how would I plug that into my calculator? Let's say if I had log 5 of 6, that would be the log of 6 divided by the log of 5. The natural log, so ln, works in the exact same way. All right, except the natural log, the base of an ln is e. E is an operator. It's an exponential function. Okay, let's go on. Change the following to common log, then to natural log. All right, yes, and then sorry about that. Got disconnected mid-sentence. Okay, so I just want to change this using our change of base properties. Okay, so I know the common log, the common log is just log. So that's log of x divided by log of 3. Here, log, this is the common again, of 4.7 divided by log of y. Okay, natural log, I don't know if I'd ever ask you to change something from a common log to a natural log, but if that were the case, it'd be the ln of x over the ln of 3. And here would be the ln, natural log of 4.7 over the natural log, or ln, of y. Okay? Evaluate through decimal places, use a change of base. So I'm going to go the log of 175 over the log of 20. All right? Now I'm going to show you how to plug this in your calculator, so I'm going to pause here. Okay? And also log of 175. Close it. You have to close the parentheses after 175 divided by the log of 20. Close it. Press enter. I got 1 point, and it said 3 decimal places. Now everything's going to get messed up. So, all right, like I said, it was all going to go haywire there, and it sure did. So we're going to go ahead and do these, change the base, and then we'll do the calculator after. All right, so I'm going to go log of 0.045 divided by the log. Okay, this one will be the log of 64 over the log of 1/8. All right, now I want you to go plug those in your calculators and go and then check your work once you're done. All right, so here are my answers here, negative 2.237 and then negative 2, because 1/8 to the negative second power actually is 64. All right, so product property. So you know you've seen these before, properties of our logs, product property. If I have x times y, multiplication within logs becomes addition. Okay, x times y, I can expand it as log of x plus log of y. Division becomes subtraction. And lastly, one of my top properties, the power property, where I can take a power and drop it like it's hot to the front. Okay, take an exponent and drop it like it's hot. So let's expand these. So I have the ln of x squared times the ln of, or natural log of, natural log of x squared times y cubed. So I can expand that as the ln of x squared plus the ln of y to the third. Remember, if there's multiplication here, multiplication means addition. Well, I have exponents attached to each of these. So with an exponent, I can take each exponent and drop it like it's hot. So it's 2 times the natural log of x plus 3 times the natural log of y. And then I would leave my answer like that. You don't want to write it as 5. You just want to leave it. Okay? This one's a little bit different, but similar in its own right. Now I have division. Remember, if multiplication means addition, then division means subtraction. Okay, so I have the log of the square root of x minus the log of y. Well, if you'll remember, and you may or may not, the square root of x is really x to the 1/2, or the cube root of x is x to the 1, x to the 1/3. The fifth root of x is x to the 1/5. Okay, so the index is the denominator. All right, the exponent here on our variable, that's in our numerator. Okay, so really this is log of x to the 1/2 minus the log of y. So I can write it as 1/2 log x minus log y to the g. All right, I want you to try this one here. Expand it, pause it, see if you get that right. All right, so here is my final answer. Okay, notice how there is no exponent in front of this log. There is no exponent on the x, it's just a 1 there. The 6 applies to the y, the 4 applies to the z. All right, here we go. Now the last one we were expanding, so now we're condensing. Okay, remember if I have a number in front, that means I dropped it like it's hot. So this is the ln of x, or natural log of x squared, plus the natural log of x plus 1. Remember that addition means multiplication, so I'll do this as a natural log of x squared times x plus 1. And I'll just check on my work from last year. You can just leave it like that, okay? All right, so I have this 2 out in front of everything, so I'm going to hold off on the 2, and I'm going to condense everything in the parentheses first. So I know that subtraction means division. Well, I'm subtracting this, and I'm subtracting that. That tells me that everything before the subtraction, so my x, has to be in the numerator. Everything that is subtracted is being divided, meaning this is in my denominator, the x plus 1, and the x minus 1 is also in the denominator. Okay, I don't write it like this. That wouldn't make much sense. All right, so if something is being subtracted, that tells me that it's going downstairs. All right, now this is all 2 times this. Well, that means 2 was my exponent, so I'm going to write this as a natural log of all of this to the 2nd power. Okay, now I can multiply these out, and I could, get really fancy with it and do some foiling, but I'm not going to have you do that. Let's just leave our answers like this for the sake of time, because we love math. This is a really long condensable one. I'm going to go on and talk about this page instead. Okay, I want to talk about this example, this last one here. I want to remind you of some properties. Remember from the front page, the log base 5 of 5 gave us 1. Well, I mentioned that ln, if I have the ln of e, right, well, the natural log has a base of e. So if I take the natural log base e of e, that's also going to be 1. So if I rewrite this and simplify, that's going to be the ln of e to the 5th minus the natural log of 7. Remember, division means subtraction. 5 is here. Drop it like it's hot to the front. 5 natural log of e minus the natural log of 7. Well, if I take the natural log of e, that's just 1. So 5 times 1 is 5 minus the natural log of 7. And that's what I would write if I were to simplify that one. All right. There will be some practice problems. Let me know if you have any questions. Adios. Have a great rest of your day.